Problem 1 was about what data types are appropriate for storing different kinds of information. Hopefully you're familiar with all of these. I think a couple of people got tripped up trying to use data types other than Boolean to represent whether or not something's happened. So let's say you want to represent whether or not a member of a club has paid their membership fee, or whether or not an object has collided with another object. You could use a string for that. You could say yes or no. You could use an integer for that. You could use like 1 to mean yes or 0 to mean no. But a Boolean is a more appropriate data type for all of those, both because it takes less memory. It only takes 1 bit of memory, and also because it can only represent things that are true or false, whereas int and string could represent other things. And we wouldn't want to let a variable take on values that might potentially not make any sense for the situation. Another 2 data types were this 2-dimensional int array. And any 2-dimensional array you can imagine like a grid of some kind. So here we'd have a grid of variables that can store integers. But there wasn't anything that was appropriate for a grid of integers. An array list, you can imagine like a 1-dimensional list. And in this case, each variable contains an integer. And this would be appropriate, for example, if you wanted to store the ages of everybody in a classroom, or the student IDs of everybody in a classroom. Although student ID, depending on how long the ID is, you might not want to use an integer, you might want to use a string instead. Okay, problem 2. Problem 2 was about recognizing common syntactic mistakes on individual lines. So for example, the statement if a equals 5, then do some stuff, looks just fine, but the problem is single equals sign is an assignment operator. It means save the thing on the right inside the variable on the left. So it's not appropriate to have that inside an if statement. In some languages, this would actually return true or false, and that would be okay, but not in Java. So in Java, in order to do a comparison, you have to have 2 equal signs like this. Later on, you'll learn that for object data types, you'll need to do something other than 2 equal signs. But the important thing for this test was single equal sign means assignment, double equal sign means comparison. Okay, here are 2 examples of us assigning things. Do these represent errors? Well, right away, I'm noticing that we haven't actually declared either of these as variables. So if I declared this as an int, that would be okay. If I declared it as a double, like this, that would also be okay, because you're allowed to store an integer inside a double variable, because an integer is a type of decimal number. It's just a decimal number that has no decimal part to it. Here, if I had previously declared b as an integer, I wouldn't be able to store the value true inside. So a couple of the things that people missed were noticing whether or not a variable had actually been declared, and then noticing several lines up whether it was an appropriate data type for the value that was getting stored inside it. Similarly, n++, that's just fine if we had if we declared n to be a numeric data type. If I had instead earlier on declared it this way, wouldn't make any sense to increment a Boolean data type. It wouldn't make any sense to increment a string data type. Again, at least not in Java. In some languages, you could increment a Boolean. So if you're studying for next time, I'd say things to know are single equals versus double equals, and then double checking the data type. Has it been declared? Is it the right kind? The intent of question 3 was for you to do some very basic code tracing similar to the following. So everything I've written down here is syntactically correct. If you didn't know that you're allowed to declare and initialize variables like this separated by commas, you definitely can. Here's my recommended approach for this kind of code tracing. Remember that single equal sign means assign the thing on the right, or rather assign the value on the right to the variable on the left. So let's over here keep track of the current value of each of the variables. So a will be 5, b is 1, and c is 2. The first thing we do is take the value a, which is 5, and store it inside the variable b, which is currently 1, but as you see, I'm replacing it with 5. Okay, so we've done that one. C gets stored into A, so 2 gets stored replacing 5. A gets stored into C, so the current value of A is now 2. It gets stored back into C. C is already 2, so it doesn't do anything. And then B stores into A, so 5 replaces 2. So at the end, A is 5, B is 5, and C is 2. But I think if you don't do it one step at a time, there are a variety of ways that it can go wrong, and I think people who missed this question weren't thinking about it kind of systematically and carefully enough. In problem 4, I was testing to see whether you could trace what happens to the inputs from a method call. So here I'm declaring a method called print. It takes 2 inputs. We usually call these parameters. The word parameter is a variable that's declared to hold an input. The inputs are usually called arguments. So here the argument 2 gets assigned to the parameter A. And after I give the declaration, I used it twice and I sort of asked what would display. So here, 2, because it's the first thing inside the parentheses, gets automatically assigned to the parameter A. The string high gets automatically assigned to B whenever I run the method or call the method print. So A gets assigned 2, B gets assigned high, and then this is going to display the value of B, which is high, followed by a space, followed by 2, and then a colon, and then a 2. So this would end up displaying high space 2 colon 2. This one, 3 would get assigned to A. Oh, I should say that when the method's done running, these variables go away, and their values go away. So on the next call to print, they get redeclared and reinitialized with new values. So 3 gets assigned to A, yo gets assigned to B, and it should display yo 3 colon 3. That's problem 4. Problem 5 was another code tracing problem. Again, it's totally okay to declare several variables on a line separated by commas, and you can initialize some of them and not others, and that's okay. Let's follow my recommended code tracing practice, where we'll keep track of the current values of all of the variables. So A is initialized to 5. B and C aren't initialized at all. As you'll learn on the first day, int is a primitive data type, and primitive data types have default initialization values. So they both get automatically initialized to 0. Here we save A into the value of A into the variable B, so that becomes 5. Here we subtract 1 from A. That's also called decrementing, so we'll decrement A to become 4. Here, remember, you evaluate what is the resulting value on the right, and that value gets stored into the left. So here I find B. B is 5. The opposite of B would be negative 5. And so that's the thing that gets saved back inside B. So B becomes negative 5. And then finally, I'll take the current value of B, which is negative 5, and I will subtract A, which is 4. So minus 5 minus another 4 becomes negative 9. Some stuff that beginning programmers miss is they don't realize that each line evaluates by itself. So saying that B equals A doesn't forever link together B and A. All it means is take the current value of A on this line and store it inside B. But then on the next line, when you subtract 1 from A, that doesn't influence the previous value of B, because this line has already executed. It's already done whatever it's going to do. And now we're, again, treating them as totally separate variables. Problem 6 was about acceptable ways to call a method. And what I'm checking is, are you going to check the inputs to make sure they match? And what can you do with this output data type? This is called the return type. It is the type of thing that gets returned whenever this method is called. So you might not know this, but it is totally okay to run the method foo and ignore the return type. So it still is going to return some integer value, but if I run it without doing anything with that value, the value just gets ignored. So here I could say hi 2. And what you'd check to make sure they match is the first argument, the first input here, is a string, and that matches the first parameter, which accepts a string. The second one is an int, and the second one in the definition is an int. So I'm passing it the two values that it expects to take as inputs. So that matches. So this is okay. A different thing that would be okay is, let's pass it the same two inputs, but now let's put it on the right-hand side of an equals. So now whatever it returns is going to get stored into a variable, but I just have to check to make sure that the variable that is storing it is an int. It's okay for me to name my int here A, and you might think, doesn't that conflict with the name up here? But the answer is no, because these are different parts of the program. So this is a local variable A that's only defined for foo, and then as soon as the closing brace of foo happens, the variable A is no longer defined. Programmers use the word scope to refer to what parts of the program are different variables defined inside of, and we'll talk about scope later. So this one is also okay. What would not be okay is, oh, let's do one more that's okay. So one more thing that would be okay is to put foo inside a system.out.print line, because it's still going to return an int, but now that int that gets returned is now the input to the system.out.print line, and so it gets displayed. So all of those are okay. Here are a bunch of examples of things that are not okay. I could not, for example, say string A equals foo. And the reason why not is because foo is going to return an int, and Java does not automatically convert between data types, usually. So you can't store an int inside a string like this. So that's a no. What else could I not do? I could not run foo with the inputs in the opposite order. So here I'm giving it 2 and 5, but 2 is the first argument, the first input, and the declaration here is expecting a string as the first one. So can't pass them in the wrong order. I can't just forget to pass one of them. So I couldn't say hi because that's the wrong number. Here I'm passing a string as the first one, but I'm not passing any value for the second parameter there. So that one's also not okay. So those are the things that you got to check every single time you're looking at a method. And this is just a silly method that doesn't do anything. But in actual programming, a large part of how you think about what's going on in the code is you think about what are the inputs, what do they mean, and then what's the output, what does it mean? And so that's sort of the most basic thing you'll do is check to make sure the inputs match and see what you're doing with the output. Problem 7 was code tracing a fragment that involved if statements. Part of what's difficult about debugging is if you have some belief about what your code is actually doing, it's very hard to put that out of your mind and go step by step and trace what is the code actually doing. Because if there's a bug, you know something's not working. And so whatever assumptions you're making about how the code works, maybe one of those assumptions is wrong. And so question 7, I think question 7 wasn't exactly this, but I had a code fragment where I told you what was supposed to be happening. And I think lots and lots of people just were influenced by what they believed was supposed to be happening. So here's an analogous example. Let's say I have an int defined called player, and I'm trying to switch player. So here it says if player is 1, let's make it 2. Conversely, if player had been 2, I'll make it 1. And so by the time I'm done with this, if I'd initialized player to be 1, it'll get switched and get printed. So if player was 1 at the top, it should print 2 at the bottom. If I'd initialized player to be 2, then this if statement will be false. This one will be true, so I'll switch it to 1, and it'll print 1 at the end. Okay, so there's a bug here, but if you let your understanding of what's supposed to be happening guide your interpretation of what the computer is doing, you won't find the bug. Let's actually find the bug by tracing it carefully. So if player has been initialized to be 1, here's what will happen. I will say, is player equal to 1? The answer is yes. So now I'll assign 2 to player. So now player is 2. But then remember, so I've done this line, and this line. But the code just keeps on going. And so now it asks, is player equal to 2? And the answer is yes, because just a second ago, we assigned the value 2. And so then we'll take the value 1 and we'll assign it all over again. So when the input was 1, by the time this code is done executing, the value will still be 1 because we will have assigned 2 and then reassigned 1. So that's the kind of error that was happening in problem 7. And I think the take-home lesson is when you're tracing code, you have to be very careful and go step by step and not be guided by what you think should be happening, but by what the computer actually does. The solution to this, well, one of the solutions to this would be to put an else in there. So, let's pretend this is all kind of one line here. So if player equals 1, assign it 2. Otherwise, if player is 2, assign it 1. Whenever you have an else or an else if, that guarantees that only one of the two blocks are going to execute here. So if this if statement were true, it's not even going to look at the second if statement. If the first one was false, that's when else evaluates, and we would check the second if condition. Okay, let's go to the next problem. Problem 8 was understanding the parts of a for loop. I think a lot of students are used to looking at a for loop as a particular pattern that they just repeat without a clear understanding of what each of these parts means or the order in which they run. So this first part of the for loop this is usually called your loop variable or your loop counter. It can be any valid Java statement, but we'll get there later. You can think about this as the initialization. This is a Boolean expression, which just means that it can be true or false. It's asking a question. Is k less than 3? We'll call this one the loop test, and it's testing should it go through another repeat of the loop. This we'll call the update condition. And then this here is the body of the loop. That's the thing that actually gets repeated. So the order these things run in is first the initialization runs, then the loop test runs. If the loop test is true, whoops, the lights have gone off. If the loop test was true, which it is here, k is 0, we ask the question, is 0 less than 3? The answer is true. Then the next thing that happens is the body executes. When you get to the closing brace, that's when it goes back up and executes the update condition. Then it goes back to the loop test. And if it's true, it executes the body, then the update. Loop test, body, update. Loop test, body, update, like that in a loop, until eventually the loop test is false. And when the loop test is false, that's when you wouldn't run the body. You would exit down here and keep going with whatever other code was happening. Okay, so how many times does something print here? You can keep track of k. So k gets initialized to 0. Loop test is true, and so we print one thing when k is 0. Then we increment k. Loop test is true, and so we print it. Then we increment k. Loop test is true, so we print it. Then we increment k. Loop test is not true because 3 is not less than 3. 3 equals 3, and so we exit. So we didn't print anything. So these are the only values that got printed. This is the normal pattern for repeating 3 times. You initialize to 0, and you say it's less than however many times you want to repeat. So if I wanted to repeat 87 times, I would make this 87. Notice that if I start from 1, let's go back to 3. If I go from 1 to 3, that doesn't print 3 times. That only repeats 2 times. Because k will be 1, I'll repeat it. K will be 2, I'll repeat it. And then when k is 3, I exit. So I only repeated for 1 and 2. So that's something to be careful about. You have to look carefully at both and then think what's happening. What if I had this? How many times is that going to repeat? The answer is 9. But that's only because I'm updating 1 at a time. If I had said k equals k plus 2, now if I think about the values of k, k will be 1, and then 3, and then 5, and then 7, and then 9. And for each of these k values, I'll execute the body. So it's going to print 1, 2, 3, 4, 5 things. Then as soon as k gets assigned 11, the loop test will be false, and we won't run anything. So this will repeat exactly 5 times. So that's the kind of thing that I want to train you to do, is don't just look at it as a pre-built pattern. You got to think about what each thing means and what actually happens when it runs. Problem 9 was another code tracing problem involving if statements. And I was trying particularly to make sure that it was complicated enough you would have to carefully go line by line in order to keep track of the values of variables. So let's do my approved method for code tracing. Here are the variables. Let's keep track of their values. So there's 2, here is another 2, and then b is -1. So on the first line here, b gets assigned opposite b. So the opposite of b is +1. That gets saved back inside b. So this becomes +1, and we've done that line. Okay, so now I'll take the current value of b, which is 1, and multiply it by a. So that hasn't changed anything. That's still 2, and that gets assigned to a. So a is still 2. Okay, is it true that a equals the opposite of c? The answer is no, because 2 is not equal to -2. Let's pretend that this had looked like this. If I'd said, is a equal to c, now the answer would have been yes, and then we'll go back and say b gets opposite b. So we'll take the opposite of 1 to be -1 and assign that back into b. And then we'll take -1, current value of b, multiply it by c, so that's going to be -2, and we'll store that back inside c. So again, it's just carefully going step by step and making sure you're using the most current value of whatever variable you're looking at for whatever expression you're trying to decide about. Question 10 was about how you can use a class definition to create new objects and add those objects to an array list. So a couple of things. If we say public class student, that's defining a new data type called student. And every student has some variables. They've got a name that's a string and a grade level that's an int. This part is called the constructor. It is a method whose job is to construct a new student. What does it mean to construct a new student? It just means that we're going to create a new set of variables and we're going to assign them their values, and that will be the student. So the way that you run a constructor is somewhere else in the code you have to say new, you have to use the keyword new, and then you have to run the name of the method, student, like this. And then because I'm out of space here, my student is going to be named Bob. Yep, that was short enough. Okay, so I've run student. Bob was the argument or the input. That input gets assigned to the string n. Now that n is going to get assigned to the new student's name. So Bob gets assigned here. That same Bob gets assigned to name, and name is defined up here as one of the not class variables. I don't know what vocabulary you guys were using in intro Java. We call these attributes, which sort of makes sense. It's an attribute of that object. It's like a fact, a basic fact about that object. Notice that even though I have 2 attributes, I've got 2 variables that define every student, my constructor does not take 2 inputs, because whenever I create new students, they're by default assigned a grade of 9 all the time. So I could have had another input for the grade. It's just that this class definition didn't happen to do that. So you have to pay attention to what does the constructor look like, not how many variables does the class have. Okay, so I've created a new student, Bob. But if that's all I wrote over here, that code really wouldn't do anything because I'm not saving the new student anywhere. So this has to be on the right-hand side of an equals sign. So when the constructor returns the new student object, it gets assigned to a variable. So I'm going to run out of space here, so let's try and do this. Whoop. So because the thing that it returns is data type student, I will define a new variable, s, whose data type is student. Now remember the pattern. The pattern is like the first thing is the data type, the second thing is the variable name, so like int n equals 5. Here student is the data type, like int, and s is the variable name, like n, and the value is an actual new student object that gets returned by the constructor. Okay. So far, so good. So I could do that. I could create another one. I'll call this student P, new student. I will call this one Mal. All right, so this is a good example of you can run the constructor as many times as you want to create as many copies of these sets of variables as you want. So we're creating a bunch of student objects. How do you put them into a list? So a list, an array list, you declare this way. You say array list, and then inside triangle brackets, you put the data type. The data type is what type of variable are you going to have in a list. So here's our list. It's like each location here, and remember the locations are numbered starting from 0. Those are called indexes. So each index corresponds to another variable. So I could say student number 0, student number 1, student number 2. But that's only if your array list has data type student. If we had array list of integer, then each variable here just holds one integer. Okay, so here, just like up here where we're following a pattern, data type, variable name, this entire thing is the data type. I'm saying we have a list of students. I will call it L for list, and then going on to the next line here, you have to run a constructor for array list. So you say new array list. And then it used to be that you had to include the data type inside the triangle brackets all over again. In more recent versions of Java, you don't have to do that. So you can have empty triangle brackets. But then you need opening and closing parentheses because array list here is really running a constructor, just like we ran a student constructor over here. So if you don't include the parentheses, Java doesn't know that you're trying to run a method because parentheses are is how we know that methods are running. All right, so far so good. So we've made 2 student objects. We've made an array list, but when you first create the array list is actually empty. It doesn't point at anything at all. So there's still a list. It's just a list of size 0. So it's like an object exists, but its size is 0. So then the way that you add things to the list is that you say list.add. So I could add the s variable, and I could add the p variable. And what that would do is that would create element 0 and element 1 in my list. Element 0 is going to point to the S student. Element 1 points to the P student. So over here, it's a little bit messy, but hopefully you can read it. That would be one way to instantiate. Oh, you don't know that word. I use the word instantiate to mean create an instance of. And an instance is just an object. So I'm creating new student objects. So I'm instantiating the student class. So this is one way of creating several student objects and then a new array list and then putting them into the list. Here would be another way of doing that same thing. Okay, so let's say I moved my array list declaration up here, and I know it's running off the edge, but it's array list student L equals new array list and then parentheses. So I create my empty array list first, and then I say, let's add something. What are we going to add? I know that whatever is on the inside here has to be a student object, so I can run the constructor straight inside here. I can say new student Bob. And then if I want to add another one, I could say l.add and then run the constructor again. New student Mal. And you could do that as well. So you could save your objects inside student variables and then add the student variables, or you could skip defining student variables entirely and just return the student objects directly to the add method. Oh, let me end by saying, I know if you're not used to looking at it, it looks very complicated because there's a lot of words, there's a lot of symbols. Conceptually, I want this to feel very basic for you because it's a thing that we're going to be doing a lot, and you don't want to have to think about it every time you see it. It's going to be pretty normal to say, let's define a new class to represent a point in two-dimensional space. Now let's have a loop that loops 100 times and creates 100 objects and puts them in a list. Because object-oriented programming, you think in terms of objects, and it's very normal to operate on lists of objects. Okay, problem 11 is about tracing what happens to a method's inputs and outputs. But the wrinkle here is, well, I'll show you a couple of wrinkles. So first, let's just practice evaluating a basic one. So if I have f of 2, let's do f of 3 comma 2. What's going to evaluate? So here are the two inputs. 3 gets assigned to A, 2 gets assigned to B. So now A is 3, B is 2. What we're going to return is another method. So we're going to evaluate g of A and add that to g of B. So what happens when we run g of A? Well, A was 3, right? So g of A, I'm going to run over here, and I'm going to assign that 3 over there. Oh, lights went off again. So if c is 3, what are we doing here? C times c minus 1. So 3 times 3 is 9, minus 1 is 8. So we're going to return 8. Where does it return to? It returns to the place that ran it originally. So here, again, to trace it, 3 got assigned to A. So now I run g of 3. That one over here, we calculated 8, and 8 returns here. So you can imagine this now as getting replaced by the return value of 8. Okay, so now we're going to run g of B. 2 got assigned to B. So now we're running g of 2. 2 times 2 is 4, minus 1 is 3, and so 3 gets sent back here, and now we have 8 plus 3, which is 11, and so this is going to return 11. Okay, so far so good. So I think the wrinkle in this one was the following. So what if I asked you about this? First, you have to understand what this is doing sort of visually. The f function takes two inputs that are separated by a comma. And so that's kind of how you look at it visually. The first input is whatever you get as the result of running f on 3 comma 2. And then the second input is the number 3. So in order to start with this one, first we have to decide what is f of 3 comma 2. We just did that a second ago, remember? So if I'm only evaluating this part, 3 gets assigned to A, g of A was 8, 2 gets assigned to B, g of B was 3, then 8 plus 3 was 11, and so this thing returns 11. So you can imagine this now getting replaced by its return value. So now I'm running f on 11 comma 3, and so there 11 gets assigned to A, g of 11 is going to be 11 times 11, which is 121, minus 1 is 120, so this is going to be 120, and then 3 gets assigned to B, g of 3 is 3 times 3 is 9, minus 1 is 8, so that's 8, and so this is going to return 128. But the most important thing here, don't worry about the arithmetic, the most important thing is realizing what happens when you're composing the functions. Let's do one more, just to practice. Okay, you might want to pause the video, give this one a try. I'm going to write the answer in just a second. F of 1 comma 1 ends up being 0. F of 2 comma 2 ends up being 6. F of 0 comma 6 ends up being 34. Question 12 was another question about how do you successfully run a method by looking at the input, looking at the output, and knowing how to use it. So let's pretend we have a method called year to second, where you give it some number of years, like 5, and then it will tell you how many seconds are in that number of years, and that would be the return value. So could I run it this way? I initialize y to be 2, I run year to second on y, and then I print out y. The answer is definitely no, but this is an example of the kind of wrong answer that I was sort of testing for. What you have to realize is that when you run year to second, whatever the input is what gets assigned here, and then whatever the output is, you have to store the output so that way you can use it. So we could have int s for second, and we could do s out second. Don't get mixed up by the variable names. It would be a little bit perverse to do this, but I could define, let's actually write a full word here. So I could say int second equals 2, and then I could say second, let's call it seconds. And then here I could say int years, and then I could print out years. And despite the variable names, this would be correct. I'm setting the variable seconds to be 2, but then because I'm passing that value as the input to years to seconds, that means that this method is interpreting this number as if it's a number of years. So it doesn't matter what we've named the variable. You could call this variable Sally. You could call it Bob. You could call it whatever you want. So the name of the variable is just for you, the programmer. What the program cares about is the number inside the variable. And whatever number you pass as input is getting treated like a year because of how the method is implemented. So whatever I pass as the input is the year. The output is the number of seconds. So I'm taking the number of seconds and I'm saving it into a variable that's called years, and then I'm printing years. So this works, but would be terrible style because you usually want to name the variables for the things that they actually represent, not something weird. I don't know if I need to say anything else about this. Okay, yeah, that's it. The end. Problem 13 is about code tracing nested if and else statements. And the tricky part is keeping track of where you are in the code. So let's do this example that's similar to the problem. Say x is -1 and y is -2. Okay, let's code trace. So is it true, here's my pen, is it true that x is larger than y? The answer is yes, -1 is larger than -2. So because the if statement was true, now we are inside that block. All right, is it true that y is larger than 0? The answer is no, and so we will skip that if statement. So now we're here. The else condition runs whenever the if condition it was attached to evaluated to false, and that was now. So when this if statement was false, we jump to the else, and now we print b, and then we keep going, and then we print c, and then we're done. So that one prints B and C. Let's do a couple more. Okay, you might want to try and trace these on your own. What if x is -2, y is -1? What if x is 3, y is 2? Go ahead and pause the video. Okay, now I will trace them for you. So is it true that x is larger? Oh, sorry, we're here. So is it true that x is larger than y? In this case, the answer is no. -2 is not larger than -1. And so we skip everything and it prints nothing. Okay, what about this one? Is it true that x is larger than y? Yes, 3 is larger than 2. So now we're here. Is it true that y is positive? The answer is yes, and so we display A. And now we're at the end of the block. We skip the else block because the if statement evaluated to true, so now we're here, and then we print C, and then we're done. So this one prints AC. I think most people who missed this problem missed the fact that once you've evaluated your if or your else condition, you have to keep going at the next place that execution would logically go to. So a lot of people kind of missed the end bits. This question asked whether different for loops displayed 10, 9, 8, 7, 6 all the way down to 1. Here's an example of such a potential for loop. Decide, does this actually display 10 down to 1? Hopefully you said the answer is no, because if you remember, well, I don't know, maybe you didn't watch the previous problem discussing for loops. A lot of the for loop assessments I'm doing is testing to make sure that you understand how to trace a for loop and know what each thing here does and what order they run in. So this runs first, it's the initialization. This runs second, it's the loop test. And the loop test, whenever it returns true, the loop will evaluate. And then the third thing that runs is the loop body, and that only runs if the loop test was true. And then the fourth thing that runs is the update. So here I'm starting at 10. I'm asking, is k larger than 1? If the answer is yes, then I print k, and then I subtract 1 from k, and then I ask, is it greater than 1? If the answer is yes, I print it, and so on. So hopefully you recognize that this won't ever print 1, because k is going to be 10, we'll print 10, we'll subtract. Then k is 9, we'll print 9, we'll subtract, and so on until eventually, let's think about the last couple of loops. When k is 2, 2 is larger than 1, so we'll loop, we'll print 2. Now we subtract so that k equals 1, but we haven't printed it yet. Is it true that k is greater than 1? The answer is no, because k equals 1. So 1 is not greater than 1, and so we exit, but we never actually ran the print statement when k was equal to 1. So this is an example of not printing the 1. We could fix it by doing this, by saying k greater than or equal to 1, because then when k equals 1, that will be true, and we'll print it when k equals 1. What's another thing we could do? Maybe you're thinking we could do this. That doesn't quite work. Well, here, let's do this. Okay, so here k is 11, and it goes down to the smallest value it can be when k is larger than 1. So the smallest thing k can ever be here is 2. Okay, so if the largest thing k can ever be is 11, 11 minus 1 is 10. So the first thing it prints is 10. The last thing it will print is when k equals 2, because if k is smaller than that, k will be 1 and will exit. So when k is 2, 2 minus 1 is 1, and so the last thing it will print is 1. And so this one works. So that's another way that you can think about tracing for loops, is you could think about it kind of step by step, or you could think, okay, what's the first thing that it's going to be equal to, and then what's the last thing that it's going to be equal to. Okay, problem 15 involved understanding a basic class definition. It was too long for me to actually write on the whiteboard, so I typed it out here. So let's say we have a class representing an online order for something. But I can only ever order multiple items of a single kind. So the variables that an order object has is the name of the item that we're ordering, the price of the item that we're ordering, and the quantity of the item that we're ordering. Here's the constructor. The constructor only takes 2 inputs, the name and the price, and the quantity by default is 0. And then the way that you actually say that you want to order these things is this method adds to order, which takes an integer input and adds that number to the quantity. Change price gives us a way of changing the price of the order. And then cost returns how much overall is it going to cost us to make the order, which is just the quantity times the price. Okay, so let's code trace. Over here, I'm creating a new order object for a pen that costs 99 cents. Okay, so let's imagine that. When I do that, the n variable contains a reference to a new object. We'll talk more about references when the year starts. And this object is an order object. And so it's got an item name. Ooh, you can almost read it. It's got a price. Let me try and do better here. And it's got a quantity. So all 3 of those variables are wrapped up inside this object that we've just created. The item name is pen, the price is 99 cents, and the quantity is 0 when we first create it. Okay, so let's look and see what happens as we run these methods. Remember that all these method names over here, add to order, change price, get cost, these are only methods that an order object can run. So I can't just say adds to order. I have to specify which order object is supposed to be running the add to order method. Because the whole point of add to order is I'm taking a number and I'm saying some particular order needs to increase its quantity by 7. And so it wouldn't make any sense for me to just have that method by itself, because there's potentially a lot of different order objects. Remember, I could run the constructor a bunch of times. So you need to have a variable. In general, if you're not used to seeing the pattern of something dot something, where this is an object and this is a method. This is a very, very common pattern. The dot operator here means follow, or it means go to this object and have it run that method. Okay, so far so good. So tracing, we're going to run add to order 7. So this 7 gets passed as input to int n here. And so we'll take that 7 and we'll add it into quantity. So now quantity is 7, and we're done running that line. Change price, the 2.00 is going to get passed into new price here. And that's going to replace the price attribute up here. So price is now going to get replaced to be 2. And then add to order 3, I'm going to take my 7, here you can see down here, add to order. I'm going to pass it 3. The 3 gets added into the existing quantity. So I got 7 equals 7 plus 3 is 10. And then finally, when I run get cost is going to look at the current values of quantity and price. So it's going to reference these values up here for the attributes. It's going to multiply them and then return it. So 2 times 10 is going to return, $20, 20.0. So this problem was just making sure that you have a mental model, that you imagine creating an object, running its methods, you can trace what happens to an input, and that you understand how an object can update its own variables based on the inputs of methods. Problem 16 is all about, do you recognize how to run a constructor to create a new object? So let's say I have a class called student. Students have a name and a favorite color and a grade level. Here's the constructor. The constructor, you might notice, only takes 2 inputs, the favorite color and the name, because n gets assigned to name and fav gets assigned to favorite color. By default, every student constructed has a grade level of 9. So you can't set the grade level in the constructor. You would have to set it somewhere else. All right, so the question is, what's valid? Hopefully you recognize the problem with this. New student, Bob Red, that all checks out. But the problem is, what the constructor to student returns is not a string. It returns a student object. So I can't store it into a string. A student object is its own data type. So you can imagine this is a student object, and the student has inside it, here's student, the student has inside it 3 variables. It's got a string that's a name, it's got the favorite color, and it's got the grade. So a student you can think about as a collection of 3 variables. Okay, so this one, not good. We could say student. And now this is okay. Let's look at other things that would not be okay. I have to pass it the right number of inputs in the right order. Oh, this was not okay still. You might notice I said that right after saying in the right order. So here I've passed the name followed by the color, but here it looks like I'm supposed to take the color followed by the name. So this is still wrong. This is more of a logic error rather than a different kind of error. Like it's still going to run and it's still going to print stuff, you know, and do whatever it's supposed to do. The problem is the whole time we're creating a student whose name is Red and whose favorite color is Bob. And that probably is not going to make sense for whatever we're supposed to be doing with these objects. So let's reverse it, Red and Bob. But the thing that I'm testing you on in this question is, can you check that you're passing the right number of inputs to the constructor, that the order of the inputs matches what the constructor expects, and that you're storing the result in a place that makes sense? The last note is you don't actually have to pass these strings directly. Instead, I could have done something like this. Here, hold on. It is totally okay to declare some variables. Favorite color is Azure, name is Bob, and then to have the variables contain the values that then get passed as inputs to the constructor. Problem 17 was a code tracing problem where if you try and trace it one step at a time, you'll notice that the loop is repeating too many times to get all the way to the end of the process. So this is an example of that kind of thing. Let's start it, and then hopefully the answer will pop out at you. So let's do, okay, so here we've got two variables. We've got a and I. A is initialized to 1, I is initialized to 200. Okay, so k, so right away when you look at this, you can think, okay, this is going to loop 100 times, because k is going up from 0 up to 99 is the last thing that k will be before it exits. So if you add up 0 to 99, that's actually 100 things, because 1 to 99 would be 99 things, plus the 0 is the 100th thing. Okay, so let's trace it. So a plus plus, so a becomes 2. I equals I minus a, so now that's 198. I plus plus, so now that's 199. A minus minus, a is back to 1. Okay, let's do another iteration. A plus plus, so a has become 2. We'll subtract 2 from I, so now that's 197. I plus plus is 198. A minus minus is 1. But if I'm asking what is the value of a and I at the end of the loop, it might be like, well, wow, what am I supposed to do? Do that 100 times? But what I want you to notice is that, well, there are two things you could notice. You could either try and ask yourself, how does this stuff in the middle simplify? Like, what is it really doing? Like, it's doing a bunch of steps, but if I was going to describe the overall effect of all of those steps, what is the overall effect? Which is just another way of saying, do you know what that part is doing? A different thing you could notice is there's a certain pattern at the end of every single iteration of the loop. So let's think about simplifying this. So a is 1. What I'm noticing is I add to 1 to make it 2, but then at the end of the loop I subtract from a again to make it back to be 1. So inside the loop, a is 2, but it always gets reset back to 1 again. So I guess one way we could think about this is if I add to a to make it 2 and then subtract at the end to make it 1, the only place a ever gets used is right here, and the only value a ever is at that place is 2. So really, I can ignore all the a stuff. I could just think about this as saying I equals I minus 2, and then I plus plus. But wait a minute, what happens if I subtract 2 and then add 1? That's just the same thing as subtracting 1. So I could replace all of this with a single line, I minus minus, because all I'm doing is adding to a to make it 2, subtracting 2, adding 1, which is now the same as just having subtracted 1 from I, and then I reset a back to its original value. So you could think about it in terms of, in that way. A different thing you could notice is I started out as 200. At the end of the first loop, I was 199. At the end of the second loop, I was 198. If we were going to go another loop, it would be 197. And so you could just notice, wow, at the end of every single loop, I seem to have subtracted 1. Okay, so let's close the problem out. If I'm looping 100 times, and every single loop I subtract 1 from I, then that means that at the end, I is going to go from 200 to 100, because that's what I get when I subtract 1 100 times from 200. Oops, you can't see it. So at the end of this whole thing, I should equal 100, and a should equal 1, because remember, a always gets reset to 1 at the end of the loop. So that's the kind of thinking you're going to have to start engaging in. Again, these are all toy problems. They don't actually do anything useful, but they involve the same kinds of thinking that you're really going to need to practice in order to do useful code. So there's two kinds of thinking that are helpful. Being able to go step by step without getting distracted by what do you think is happening. That's very useful. This is the converse of that. You go step by step, but then you step back and you say, what is all of this actually doing? You know, what does it all mean? What does it mean to add and subtract and add and subtract? And then you realize, oh, what this is really doing is it's really just subtracting 1 from I every time. So that type of thinking, being able to look at a chunk of code and be able to summarize what is it doing, what effect is it having on a variable, that's another useful type of thinking.